What's going on, everybody? Today we're going to be looking at photosynthesizers and cellular respirators and their interdependence between each other. So let's hop right into photosynthesis. We are in Miss Jones' class today. Hi, Miss Jones. Too cool for school. You're a llama today. That must feel really special. Anyways, photosynthesis, what is it? Well, these are going to be your autotrophic organisms turning CO2 gas and water using light as a catalyst to make glucose and oxygen gas. Where are we going to see this? We're going to see this in the chloroplast. And in photosynthesis, we're going to have two main reactions that take place. It is only two. It's not one only, whatever I just said. We have light dependent. This needs light. And then we have light independent reactions. These do not require light. We're going to start off with light dependent reactions. So we have light coming down to these things called pigments. Pigments are these things that want light, and they're going to take in the light, and then they're going to be like, yo, electrons, you should totally go to the ETC now. And then these electrons are going to be like, yeah, pigments, I agree. And they're going to get excited and run to the ETC. But wait, before we continue, water and pigments do not like each other. Water does not like pigment. Pigment do not like water. How are they going to settle their beef? Kind of in school, you got to settle your beef sometimes. They're not going to fight. What they're going to do is they're going to compromise. And I think that can be said for a lot of kids. They should be compromising, not fighting. Oh my goodness. I'm going off on a tangent. Anyways, H2O is going to give its hydrogen atom to the pigment, and it's going to leave as oxygen gas. This is going to be important in cellular respiration, but we will get to that later. Anyways, these hydrogen ions now are going to want into the ATP synthase. They're going to build up. What is ATP synthase? Well, ATP synthase is an enzyme, and that's going to make your ATP. But you might be wondering, well, where's the ADP? Because if you want to make ATP, you have to have ADP. Well, we're going to get to that in the light independent reaction. But like I said, these hydrogen ions, they want into the ATP synthase to make ATP. So everything made here is going to come over to your light independent reactions. We'll get back to that when we get to the ADP and how that's made. So light independent reactions. Miss Jones has another quote for us. We have arrived to the stroma. Yes, this takes place in the stroma. This is part of your chloroplast. It is this little like jelly-like fluid in it, I believe, if I'm not mistaken. Please don't take points off. Anyways, we're going to take CO2 gas, and we're going to break it down. On the top, we have glucose, a little sugar. That is released as waste. We're not actually bringing this back. The cellular respirators, like the oxygen gas we talked about, is going to be used by them. So we get ADP plus P. This is ATP broken up, basically. You have diphosphate instead of triphosphate. So, and this will come back to LDR. So, it goes through the whole cycle again, that ADP plus P. That's going to come back to the ATP synthase with the hydrogen ions, and they're going to make their ATP. All right. Well, that's enough for photosynthesis. Well, your next question would probably be, well, where does the glucose and the oxygen go in this cycle? Well, do I have something for you? We have cellular respiration. The respirators are going to be using this. And what is cellular respiration, you might ask? Well, we are turning that glucose and that oxygen into H2O and CO2. And you might be asking, isn't that the reactants of photosynthesis? And I would say, yes, that is. It's a cycle. These two are dependent on each other. Well, not really, but, at the end of the day, it's biology, not chemistry. And Corbin, all I meant by that is like, it's one of my crazy tangents that I go on. You'll see this a lot. All I meant by that statement was, they are dependent on each other in biology, but technically, if they had all the elements from other sources, they wouldn't really need that. Sorry for the confusion. That has nothing to do with the dependency. They are very dependent on each other, just so you guys know. So back to the video, guys. But anyways, who is going to be doing cellular respiration? We're mainly going to see this in animal organism cells. We're going to see this in these animal cells, rarely in the plant cells. We'll see a little bit, but not a whole lot in the plant cells, that is. And this is going to be happening in the mitochondria, the powerhouse of the cell. Everybody knows the mitochondria. And like I said, we're going to be breaking down the glucose and the oxygen into water and CO2. And we're also going to be releasing ATP here. This is very important. I didn't put it down here, but we are making ATP as well. And we have another quote from Miss Jones. This one is not as amazing. Kind of mean, Miss Jones, not going to lie. Mashuri, wake up. Like, come on, Miss Jones. This is biology, not roast Mashuri day. Okay, on a real note, she said, we are in the cytoplasm. This is where this starts. This is your glycosis happening. Remember that. Glycosis is the first step. We're going to be turning that glycosis, gly meaning glucose, cis meaning breaking down, lysis, I don't know, whatever that ending thing is, that is going to be meaning breaking down. We're going to break it down into pyruvate, 2 of them, and we're also going to get a little bit of ATP. We're only going to get 2 things of ATP. So then this pyruvate is going to enter the Krebs cycle, and it's going to do boom cycle things, and we are going to get CO2 and ATP released as sort of like waste. The ATP does get carried over back into the light independent, or the, photosynthesis reactions and stuff. The CO2 is used for the plant again. So basically they both get reconsumed by photosynthesis. This just goes to show that they are dependent on each other once again. But after all is said, we get electrons carried over by NADH. Wow, that's so amazing. They're going to move down the ETC, but wait. That oxygen is going to be like, no, you wait. We're also going to make water here. And like we saw in the reaction, we need water as a product, water as a product and CO2 as a product. We'll get to the CO2 later, but we already did CO2, right? Right? Yeah, we already did CO2. Oh my goodness, we're so smart, guys. We already got through it. We got H2O and CO2 already. That's how it happens, basically. The oxygen's like, no, I want water now. And this is going to happen in the ETC, and that might be a little confusing, but that is how it works at the end of the day. And basically, what it gets from this is like 32 to 34 ATPs. That is insane. Remember, we were only making 2 over here. This is like baby food compared to this. This is like the filet mignon, I probably said that so wrong, but you got like Gerber cheese puffs. You got filet mignon. I mean, like, come on. And basically, this is just the big cycle, We saw the CO2 up here and the oxygen, or not the oxygen, the H2O, I should say. These are going to go back to your photosynthesis, so it's just a very big cycle. Alright, so I have a little demonstration to show you guys this cycle, or not the cycle, but the interdependence on each other, why they need each other. But before we do, let's look at this amazing to-do list. Find Houdini. Pretty nice task. Calculate Avogadro's number. We got sleep. Leland, that's for you. Drink milk. Annoy Miss Jones. Annoy the intern. And do a gizmo. Also, may I just say, our classmates are looking amazing today. That chicken pooped out an egg. Interesting. So just to show you guys their interdependence, I compiled 3 groups for you guys. We have group 1, that's going to be your respirators. You got group 2, your photosynthesizers. And then you got group 3, both of them combined. So let's go to group 1. So this is your respirator. It was originally a cow, now it is dead. It does not have the photosynthesizer to provide what it needs. So the oxygen and the glucose, that is, and and on the contrary, we have this. We have group 2, the photosynthesizer. There's no respirator with this one, so this plant cannot get access to the water and the CO2 it needs, so it just died. And in group 3, we have a nicer ending here. We have Mr. Cowman, and we got some plants here. The respirator, the cow's the respirator, and then the photosynthesizer is that. They're supplying each other what they need. The cow, of course, needs the glucose and the oxygen, and the photosynthesizer needs the CO2 and the water. And, these two just supply each other, so, they're happy. And that's about it, guys, for this video. I won't do the whole subscribe thing. Again, this is a school project, so, this is also going on YouTube. So that should be interesting. Just remember, guys, it's a big cycle. respirators need photosynthesizers, and photosynthesizers needs respirators. You can't just have without them. And remember this equation. Remember this general equation. Photosynthesis is carbon dioxide and water turning into glucose and oxygen, and respiration, cellular respiration, is glucose and oxygen gas turning into CO2 and water. That's going to be it, guys. See you guys in the next one.